or early afternoon. So let's get ready for the last talk of this session. This is Raymond Hettinger telling us about Beyond PEP 8, how to write best practices for beautiful intelligible code. I was not sure it was possible to go beyond PEP 8 in beauty, so we're going to find out how. And yeah, so here he is.
Oh my goodness, there's a lot of you. I actually didn't think anybody would come. I'm going up against Benjamin Peterson, who's in the other room, so I can presume his room is overflowing, and that's why you're all here. How many of you have read PEP 8? How many of you liked PEP 8? Who doesn't like PEP 8? Why not? That's the part I don't like either, the line width part. It bugs me. Why does the line width part bug me? You have to wrap your comments at 72 characters. You have to terminate your lines at 79 characters. When does it bug me? One time it bugs me is when I'm writing unit test. When I'm writing unit test, I have to start with a class, and then inside the class there's a def for a test, and then the test starts out with a self-assert equal, and by then, most of my line is gone. So by the time I get to any business logic in my test, I'm near the end of the line. But what happens if I go over 79 characters? What if I hit 80? What if I hit 81? What bad thing will happen? Something bad does happen. What is it? That is not the negative consequence. I have never seen a little puppy die ever because we hit 80 characters. But something bad does happen. There's a reason I fear it as I start to get up around 78 characters and I know I've got a few left. I get worried. Why? I lose my readability at 82 characters? I don't buy that. Nope. Nope, there's something I worry about, something bad I know is going to happen. Larry Hastings, $5. Say your answer again, sir.
Someone will reply to your attempted check-in and say, you're transgressing against PEP 8, you have to fix this.
Somebody is going to come PEP 8 me. They are going to let my code have it. Your code is non-compliant. Maybe they'll have an import hook, so I can't get my code checked in. Maybe after it's in, they'll come in and say, oh, Raymond's line hit 81 characters, I'll PEP 8 it. And so while I'm not looking, they come in and reformat my code. So how do they get it to be back under 79 characters? They could obfuscate it. No, they'll just throw in a line break at some really awkward point. Does that make the code better? It doesn't. So I feel the fear as it starts to come up. This is not a good thing. How do I deal with my fear? Because I wouldn't want to face this terrible ending. What do? I'm feeling some pressure. And that pressure has nothing to do with writing high-quality code. It has to do with avoiding somebody who wants to come PEP 8ify you. So what do? You realize, maybe I can just commit a little atrocity, and that way no one will ever come PEP 8 me. So as I start to get up, my line starts to get a little long, I can save myself some line wrapping if I just shorten my variable names. There. Now it fits into 75 characters and no one else will PEP 8 me. Is my code better or worse? Worse. My recommendation for the line length ending outside the standard library, when you can set your own policies, is 90-ish. I picked 90 because 79 tends to be a little tight in Python if you're using four-space indents. My understanding is at Google they had a little war over this because at Google they tend to have many levels of indentation, and if you've indented several levels deep and you're already close to your line limit, there's not a lot of room for code. So what did they do about it? I don't know this for sure. I just know it on rumor. Their solution was I know, will indent less, 2-space indents. Does that make the code better? No, but it fits in 79 characters. They would rather fit in 79 characters and give up the intelligibility of that comes from 4-space indents. Even a big organization can succumb to the temptation to have an atrocity just to deal with those line endings. So I say 90 in part so that you can use 4-space indents. But I don't say 90 exactly. I say 90-ish. The ish is important. When you're doing your own version of PEP 8 for your own team, what you want is as a person's line starts to get long, for them to start to feel a little anxiety to say, maybe I should be splitting my line. Maybe I'm doing too much in one place. Use it as a hint that they're not doing something great. But if they start to stroll up near your ending, and they're going to be a couple characters over, you'd rather have them go a couple characters over than commit an atrocity. So I put the ish on there. It says, as your line gets longish, you might want to think about whether you want to chop it into pieces, because not only is it visually hard to read, but you're probably putting too many thoughts on one line. How many of you agree? Oh, this is fantastic. No PEP 8 zealots in the room. I mostly love PEP 8. I think it's extremely well written. I also think that right at the top, where it says foolish consistency is a hobgoblin of little minds, people skip right past that part. And guess where the little minds go right very quickly? Is to PEP 8. Now, I'd like to pick on these people as if they're not very bright, but I'll phrase it another way. I've had a job at a cloud computing company once where I was hired in for my Python skills. People are expecting me to be really good. And then I was asked to do a lot of things that didn't involve Python skills that I wasn't particularly good at. And I felt a lot of pressure. People were paying me a lot of money. There were expectations for astonishingly good things to come out. And I didn't know exactly what to do. At some point in your career, you will feel this sort of pressure. Psychologically, what do you really, really want to do? You very much want to deliver something that your employer, the people who are working around you, are going to like. Something that you can check off and say, I did something productive today that everybody thinks is cool. So suppose there's some low-hanging fruit, something that you can see that you just say, I know how to do that. Do you think there's a strong psychological temptation to jump for that? I know there is because I've felt it. On a lot of teams, sooner or later you get coding problems that are hard. People have varying levels of skill, and some people jump right in and seem to know what they're doing, and others struggle a little bit. That's natural. What you want is the people who are struggling a little bit to overcome and deal with the problem and at some point become very effective. How can you prevent that good outcome? It's easy. You give them some low-hanging fruit, something to go do that seems productive but isn't. And one of those things is a certain PEP located between 7 and 9. I've done a lot of consulting work. I do a lot of code reviews for a lot of companies. I do architectural reviews. I help teams organize. And here's something I've seen over and over again. The person on the team who is struggling the most, and they might actually be bright, but they are faced with problems where they don't immediately know what to do, will gravitate to PEP 8 like a moth to a flame. They will reach in to your code base and PEP 8ify stuff. And they can check off every day, what have you done? I PEP 8'd all of these modules. Did it make the code base better? Well, it might make it visually a little bit prettier, but it doesn't necessarily make it better. And in fact, the people who wrote the code to begin with come back and find their code a little bit scrambled. And when you start to use an SVN blame or HG blame or get blame, you go back and you find the name not of the person who made the code, but of the person who made all of the minor formatting changes, and it starts to wreck your code history. But worse, we get a lot of PEP 8 submissions to the bug tracker in Python. People want to contribute to the core in some way. The problem is the core has been around 25 years, and lots of the easy things to be done have already been done. So what's the easiest way for you to contribute to the core if most of the stuff in it is done very nicely? You could go through and PEP 8ify it. And so you step into code that I've been maintaining for the last 15 years, and you start to rearrange it. And so we get patches along those lines. And one theme I've discovered is that when these patches come in, a person's trying to make the code better, making it PEP 8 compliant, which is not necessarily a bad thing. But an amazing number of times it introduces bugs into the code. And so I want to caution you about that. So those are the downsides of PEP 8. I'll just get out of the way what my worries are about it right now. Worry number one is that you end up with code that's beautiful but bad. We'll take a look at that shortly. Number two, you'll have a distraction from code quality. You guys see what's up on the screen here? This is a rather famous psychological experiment. What you're supposed to do is quickly look over these colors and name the colors. Not the word, but the color. So for the very first one, you're supposed to say green. For the second one, you're supposed to say red. For the next one, you're supposed to say blue. And most people find it hard to do because the word overpowers it. And when you start to put PEP 8 in the forefront of your mind, it's very much like this experiment. It causes you to reach for something that doesn't improve code quality in an important way. Could that ever happen to you? No, it wouldn't happen to you. You're an experienced developer. Would it happen to you? No. You would never put a form over substance. It happens all the time. It happens when we shift our focus. I had some idea of playing this little video here in the background while we go along. This one is also famous, but I don't want to belabor the point. I want to actually get into code very quickly. So this is famous, I think copyright 1999. These people are playing basketball. What you're supposed to do is follow the people in the white shirts and count the number of times they pass. Try this for a moment. Count the number of passes. Okay. And the handful of people who are laughing are seeing what you're actually supposed to see. A gorilla just walked through the middle of the scene. If you were actually counting passes, most people, and when I say most, 99 out of 100, will count the passes almost correctly and not ever see the gorilla. So if you get yourself in a PEP 8ing mode, what do you tend to see? Okay, this highlights it quite a bit. You tend to see the PEP 8 stuff and not what really matters. Now I'm going to do the dangerous part of my presentation. This year, I'm speaking with no slides. This year, I'm speaking with Emacs. Wish me luck. We're going to confront a famous problem in computer science, P versus NP. You guys all know about the P versus NP problem? I face it every day because what do I do for a living? I train people. I do code reviews. I do architectural reviews. I help teams organize, and I face P versus NP every day. How many of you think P versus NP is a problem in computational complexity? Oh, then you don't know what this one's about. This is about Pythonic versus Non Pythonic. Yeah. Gotcha. And what am I about to do? I'm about to not glib anymore. Instead, I'm going to show you what I do for a living. I'm going to give away some of my bag of tricks. Hopefully you can reproduce this. Most of the things I'm going to show you are taken out of real code from client code. I've changed some of the names a little bit to protect the guilty. And in a lot of the cases, these developers who made this code are good, and these are very smart people. So we've got some code here, fairly short. And what does it do? Well, we've got a series of imports from an SDK that knows how to talk to a routing device. Okay, it makes a connection to the device, gets the routing table, but if the routing table is missing, it logs an exception, and it does a cleanup. This particular connection, if you don't clean up on the way out, can leave the router in a state that's hard to log back into. So there's some nice handling here. In addition, it determines the size of the routing table, loops over all of the routing offsets. For each offset, it finds the appropriate route. Then it calls a method to get the route's name. Then it gets the IP address. And then after that, it prints out a short little report of all of the names of the routes and their IP addresses. And then at the end, it commits any changes, cleans up, and disconnects. Fairly straightforward little script, very close to what I have seen in real life. Any questions about what it does? I didn't think so, because that's not the point of it. Is this code beautiful? No. Is beautiful better than ugly? Yes. Do we have a PEP to tell us how to make this better? Should we make it better? Yes. And should we get a code review and have somebody look at it? Sure. Somebody handed it off to the big boss, and the boss looks it over and says, hey, you know, this boss has been taught a little bit about positive leadership. Nice error recovery and logging there, Raymond. I saw a script one time that didn't log out the errors and didn't do any recovery. That was a great job. You should clean up the code formatting. It's a little rough on my eyes, dude. Oh, by the way, after you've polished it up a little bit, should we use this as a template so that we can make lots of other scripts just like this? Which is a reasonable question. Gee, thanks, the boss. How do you like the positive leadership there? Little nudge to clean up the code, but basically good job, and I'd like to use your code as a model. So I'm going to go clean it up. I will save this as a P versus NP2.py. By the way, I'll give you all this code, but the code is not necessarily the point. What would PEP 8 say about these imports? Why not just put them on separate lines? In fact, a lot of people go as far as alphabetizing their imports. That is actually important if you have dozens of imports. If you have 3 or 4 or 5, alphabetizing them is kind of a waste of time. Doesn't that already look better? Okay? One of the things that PEP 8 will tell us is to put a space on the either side of the equal sign. Keep in mind these conventions vary from language to language. In some languages, you don't tend to put spaces on the side of the equal sign. In some languages, it is very common to put spaces around the parentheses. To Python people, this looks weird. The spacing here looks a little strange. So what I'm going to do is put in get my network element, and then go ahead and tighten up the try except and else so that it doesn't have odd spacing inside. PEP 8 tells us to put some spaces in here. And it says, PEP 8 tells us that these trailing comments, they should be used sparingly, and when they are used on the same line, they should actually say something interesting other than get routing table gets a routing table. That's a useless comment, and we're better off without it. Now, we have an exception when we tried to get the routing table, so you already know it's a table fault. If you're logging it, you already know that you're recording it. Now, this gratuitous switching of quote characters, people used to really love double quotes. I don't know why. Oh, it's because they were coding in C and then switching over to Python. Single quotes are easy to type. You should basically model after what the reppers in the Python do. That represents our best practice. That said, double quotes are making a comeback. Why? Because people are starting to type JSON directly into their code, and you start typing a little JSON, and suddenly everything starts to look like JSON. By the way, say it with a long O, JSON, which is kind of cool. JSON is a person. JSON is a file format. All right, so we'll clean this up. With the rollback, which is part of the API. Is the code already starting to look a little better on the eyes? It will be PEP 8 compliant momentarily. Possibly I'll introduce some typos along the way, which is in fact a risk of PEP 8ing. And we'll put some spaces in here. And evaluate the code quality, and I think you're going to find it to be dramatically more readable. Because remember, there's a lot of things about PEP 8 I like. I don't dig the line endings, don't get me wrong. But everything else, mostly yes. Little space here after inside the tuple, like a comma space, just like you would do in English. And I think commit says lock-in changes pretty well. And now you have code that I think looks pretty darn good. Was it worthwhile for me to PEP 8ify this code? Who should do it? The intern? The most senior person on this team? The author. That's the golden rule of PEP 8. PEP 8 unto thyself, not unto others. PEP 8 is not a weapon for beating other people on the head. It's a style guide. A guide, not a law book. And if you read PEP 8 and internalize it, you will tend to make more beautiful code. But if you treat it as a law book, it will come to ruin your life. Also, there was some weird indentation in here and inconsistent. Python allows that. But now that everything lines up in line better, I think the logic of this is more transparent. How many of you like this code a lot better? How many of you would let me check it in? Oh, well, you haven't seen the unit test on it. Okay, there's unit test and docs. Now, how would you let me check it in? Okay, good. And this code is not hard. It is straightforward. Python is a remarkably good language in terms of communicating ideas, and I think it is it leads to fairly clean code. You guys didn't see the gorilla, did you? What's that? Oh, yeah, the indentation's a little off on the for loop. That'll make it better. You guys are still counting passes? Not a single one of you is seeing the gorilla in the room. What's that? I'm giving away my bag of tricks. I'm going to show you what I do for a living when I go to help out teams. I got to start to look through their code, and I don't want to fix their broken code. I teach them about unit testing, and I presume that they know their field of expertise well. What is very common, though, is people write code like this. One, because it's an obvious thing to do. Number two, it's an incremental style of development. You get the routing table, then you see an exception, and you go and add something in. But there's a part of the cleanup that people miss, and it's very easy to miss because there's a problem here that seems at first like it's beyond your control. This API came from Java. And I don't mean Java-esque in a pejorative sort of way. In fact, there was an API for this SDK written in Java, and an automated conversion tool converted the Java bindings to Python bindings so that people could write this Python code. Which is why all of the naming conventions here look Java-esque, the get routing table. It's why the code reads like Java. And Java, properly written, looks very close to this. And Java is a pretty decent language. But none of you have ever been to any of my talks before, what you're supposed to say right now. Ready? Who was that? There you go. There must be a better way. Here, you guys ready? There is a better way. Far better way. Let's try this. With open, I should probably do a from net tools, import network element. With network, I'll cheat. Doing live coding is incredibly dangerous. How many of you make sound effects when you type? As in E. For route in NE routing table. Cheat. Oh, yeah, we missed that in our PEP-8ing up here. Bam. Spacing is very important around operators. That's essential for code quality. This code does the same thing. Which code is better, the code on the top or the bottom? One of my big problems with PEP 8 It's not the PEP itself. It's extremely well written. The ideas in it are good. It's stuff you should do. One of my issues with it is the effect on the human mind. And when you get people too focused on PEP 8, what they do is count the number of basketball passes. They read the name of the color instead of looking at the color. And they don't address the P versus NP problem, Pythonic versus non-Pythonic. The code at the top is non-Pythonic. The code at the bottom is Pythonic. There's only one problem: the code at the bottom doesn't run. It won't work. But other than that, it's really good code. Why won't it work? Because the entire API was developed in Java. There were Python bindings for it that require you do your imports like this. Do we have packages up here? Dot this, dot that. Packages? Not a honking good idea. When do you need packages? You need packages when you have an enormous amount of code with potential namespace conflicts between the various parts. If your code is not enormous, for the most part, you don't need the dots in packages at all. That is becoming widely overused in Python. It was appropriately used in the XML libraries because we have several XML libraries where there are conflicting module names. If you don't have that, all you're doing is making your imports harder on the user. And in fact, in the real example, where this code was derived from, there were about 20 lines of imports, and all of them had dot this, dot that, dot that. This is actually nicer than that code. So the code at the bottom is profoundly better. It's Pythonic, way better. What all is going wrong here? One is every time you connect to one of these devices, you're going to need to do cleanups or rollbacks. That should be factored out. Well-written Python code looks like business logic. My question is, how do we transform the API itself so that we can write this sort of thing? I'm going to teach you to prefer a number of things. When there are recurring setup and teardown logic, you should build a context manager so that you can use a with statement with this. Where there are packages, you should make a single module that makes it easier to import everything so that the code can become beautiful. Where somebody is getting the number of elements, looping over a range, and looking up something by index, there's a couple things that should change. There's a name for this in Python. It's the len function. So you should define a dunder len. There's a way in Python to get something by index. It's called square brackets, and it's very readable and beautiful. So you should actually, if you have method names like this, it's a hint that you're doing it wrong. You're coming from you're bringing in your experience from a language that doesn't have these capabilities. But in Python, anything where you can look something up by index that raises index error when you go too far, and that you could do a length on, is known as a sequence. Strings are sequences, Unicode are sequences, lists are sequences, tuples are sequences, decks are sequences. Are there a lot of these things in Python? Yes, and they all have one thing in common. They're iterable, which means you shouldn't loop over stuff like this, or you shouldn't have to. You just loop directly over it. Up here, we did a get routing table. I'd like to teach you a very strong preference for properties in your API. Getters and setters are what you do in languages where you don't have descriptors. You have to do it in those languages. If you design classes in Java and in C++ and you don't make getters and setters for your attribute, you're incompetent. You're creating code that is going to be very difficult to maintain. If people start using that API and you have to change access to the attribute, you won't be able to. So that is a strong rule in those languages. Does it apply in Python? Oh, we don't make getters and setters. Why not? Because we can put properties in after the fact if we need to. A getter and setter is a hint that you're doing it wrong in Python. So the more Pythonic way is .routing table. Likewise, .getName is replaced with .name. And even if these actually do have underlying API calls, and even if they aren't attributes, we make them look like attributes through properties. The second piece of code is a lot easier to write, it's easy to maintain, and it's easy to make a lot of variants of it. Remember, the big boss asked us, can we use this as a template so we can make lots of other code just like this? The one on the bottom, yes. The one on the top will cause problems in your organization. And that's what I mean by beyond PEP-A. Beyond PEP-A is paying attention to the things that really matter, using the language features, using the square brackets, using the len function, using the magic methods, using the context managers, using properties, and not coding like you're a Java programmer. Because in some ways, there is nothing wrong with this code. It works, and it's readable. On the other hand, I think you can agree with me that the code on the bottom is profoundly better. How many of you agree? Sweet. All right. P versus NP. NP3, that's the result. P versus NP4. How did I achieve all of this? Oops. Never do live demos. It's certainly not with Emacs. What could possibly go wrong? P versus NP. Oh, is that underscore 4? We need smaller type size. There. Line lengths don't matter as long as you can shrink your type size. What is Pythonic? The P problem. It means coding beautifully in harmony with the language to get the maximum benefits from the language. What is our goal here? Our goal is something I hope I've just given you a deep lesson for. How to recognize non-Pythonic APIs. Once we PEP-8'd that code, it would pass most people's coding standards. It would get checked in, and it would live for a long time, and other people would copy that style, and we would all congratulate ourselves for it being PEP-8 compliant. And there's nothing wrong with being PEP-8 compliant. What is wrong is ignoring the gorilla, which is what is Pythonic. If you accomplish being able to recognize non-Pythonic code, then this was worth a trip up to Canada. So what do you do if you're given an API that's terrible? There's a pattern for it. There's an entire design pattern for it. It's known as the adapter pattern. We'll write an adapter class. What should we do? We should avoid unnecessary packaging in favor of simpler imports. If your users are having to type dots all the time when they import things, you're doing it wrong. There are very few needs for dots and packages in the world. They do come up occasionally. Those were introduced to solve a very particular problem, but now everybody and his brother is making a package every time they write even the smallest amount of code, and that's an atrocity. Another thing you should do is create custom exceptions in your application. Custom exceptions let you give a name to a problem that's very clear, that tells a person what the error is. We've already mentioned using properties instead of getter methods, creating context managers, and using magic methods and a repr for debuggability. Actually, I didn't mention the repr before, but get in the habit of putting reprs on your classes. It makes debugging so much easier when you have something beautiful to look at. So what did I do? At the top here, I started with the API as given, the JSON tools element, or JNet tool network element. But then I built my own exception. Not hard to do. It's a one-liner in Python. Now, I create a new class, a network element. Not the original network element, but my new one. And what it's going to do is wrap the underlying object. So when we create it from an IP address, what it does is go out and call the original code and saves it as the old network element. In other words, what the adapter does is take the bad API and give you an adapter to the good API. So think of a power adapter. When I go to the UK, they have these big honking plugs. I thought it was kind of crazy why would you have huge plugs? Americans don't need them. And then I went to make some tea. I'm like, oh, the pots of water boil twice as fast. It's not just 220 volts, 220 volts at 15 amps. You can boil a kettle of tea like that. Then I started to appreciate it. What did I need to jack in my computer, though? I needed an adapter. I needed to take my American API, plug it in to the UK API. That's what we're doing here. This part is the UK API, and this part is going to be our API. And essentially what we did here was when there was an exception, we pushed it down into our API. Ideally, you don't want all of your business logic to be cluttered with error handling logic. For the most part in Python, exceptions let you push that logic down, wrap that sort of stuff so that in the end your business logic is clear and floats to the top. So I'm putting it inside the lookup of the routing table rather than outside. And when I catch the exception, missing var, which is uninformative, I replace it with an informative exception. A great reason to wrap is to replace crummy error messages with good error messages. That's a good message and a good exception name. But also I put a property on it, and that's why over on the right we can do dot routing table. The other thing I did was put a context manager in it, the indenter enter and indenter exit. Over here on the right, there is setup logic. Every time you connect to this network element, you're going to have to potentially, if there's an exception, log the exception and clean up. If there, on the other hand, you will not want to do a commit and a disconnect. Over here, I put that logic in the exit. And the exit says, hey, if we had a network element error, let's log it out and roll back all of the work. Otherwise, let's go ahead and do a commit and then disconnect. By factoring this out every time I use this network element, I can use with, and all of that setup and tear down logic has been done exactly one time for me. The code is far clearer on the right if we push this logic down a little bit. The repr will make this thing easy to debug. Here, this is good technique. Don't hardwire the name of the class, network element. Every class knows its own name. Well, we already know in advance the name is network element. Why would I parameterize this? What's the advantage, Larry? Subclassing. Because if you subclass, the name of the class changes, and you want your subclasser to be able to use your repr. The network element is now much better. We call it with the IP address, it returns the network element, it does the enter, exit, it looks pretty, and we can do a dot routing table on it. Notice I didn't actually do any business logic inside this adapter code. All I did is transform bad API to good API. It's like the adapter from my power socket. It doesn't change the amount of power going through, it just changes one kind of socket to another. The entire amount of work done in an adapter class is transforming one API to another. It doesn't actually do the work. Now the routing table itself, what did we do for it? Well, we used to have a method called getSize. What do we call it now? Let me make this part bigger. There. Mercy for the people in the back row. Very little mercy, but some. Okay, so all we did essentially was rename the method. When you say len in Python, it means how big is something. That's a lot better than a method getSize. And when people said getRouteByIndex, what's a better name for that in Python? Right. And what exception do they expect if they've gone too far? All we're doing is changing NP to P, Non Pythonic to Pythonic. Next one up, once it has a get item in length, what is it called in Python? A sequence. And all sequences are iterable, which means now I can do a for loop on it even without calling the len or the get item directly. Who learned something new? No one knew? All of you knew that already? Okay, just checking. How much work would this is? This looks like a big block of code. I built this adapter class in under 10 minutes. I might have done 5. I'm just conservatively remembering. Look how long it takes to make the routing table. Where there's a getSize, make a len. Where there's a get item or get by index, make a get item and put an index error, and it's automatically iterable. This is 1, 2, 3, 4 lines of code in order to transform the API. It's so easy to do that if you don't transform bad APIs into Pythonic APIs, you're a fool. And I'm serious about it. That is one of the number one things I do for companies. I go and they say, we've got 50,000 lines of stinking code. I'm like, well, we could make it into 10,000 lines of stinking code and then go improve it. There's some adapter classes. Sometimes the ideas in it are good, but they are lost over here in this big wall of code. It's hard to see the business logic as opposed to on the bottom right. We can see all of that. And then finally on the class route, very simple adaptation. Where there was a get name, we put a property. And that's the Python way. I'm leaving you with this file. I'm going to give, I'm not going to publish a set of slides, but I am going to make a little website for this, which shows all of my code examples here. And the way you're supposed to review this is go click on P versus NP4, and right at the top is a little doc string that says, Raymond's recipe for making code better. Most of you can go back and apply this right away and start using the properties and the context managers and clean up your setup and teardown logic and transform code from the top code to the bottom code. Are you guys enjoying the talk so far? And Emacs has not disappointed me yet. I'll risk it. I'll do more live coding. We will go miscellaneous 1. Several things I want to demonstrate here. Top one is a function call. Function call uses positional arguments. I think it's fairly obvious what this does. This calls a function of 4 arguments. The first argument is a string, the second is a number, and it's got 2 booleans. My bet is that on your very first day of learning Python, you knew enough to understand this code. How many of you are clear that this makes a function call with 4 arguments, a string, a number, and 2 booleans? Programming languages don't get it any simpler than that. See? Simple, beautiful code. And do you notice the space after the comma? It's PEP 8 compliant. I didn't use triple quotes here, no backslashiness. PEP 8. Is that code awesome? What's wrong with it? You don't know what it does. Why not? All you have to do is look up the API. I know when I wrote the function TS, I knew exactly what it did when I wrote it. Does that improve your understanding a little bit? Python is a beautiful and readable language, but only if you meet it halfway. We can't make you write good function names or good variable names. Is the code now profoundly better? Yes. In all languages, should you use good variable names? Are you sure? Does the need vary from language to language? In fact, it does. In C, I make a type declaration, a file pointer f. Then I call a function with f in it. Is f a good variable name? It's a perfectly decent variable name because I had a type declaration that said it's a file pointer, and that was right beside where I made the call. In other words, you have more information than the variable name, you have the declaration. In Python, do we have type declarations? No. So should you be a lot better about your variable names to make up for the loss of information? Yes, in different languages, we code to their strengths and weaknesses. Where there's the redundancy in C from the type declaration, you can make your variable names. You don't need to add as much information in the variable name because you've got additional information in the type declaration. Enough said, Python creates a need for better names. What topic do you think I'm searching for on Twitter? That is an incorrect hypothesis. What topic do you think I'm searching for? Obama. Okay, so I have some people who have some personality issues. These are the people who like to work against your team just to, kind of, like, things were going too smoothly at the office. I'll put some speed bumps in. No, they're people with a good sense of humor. And Python, fortunately, attracts those because, remember, Python's not named for a mean carnivorous snake. It's named for a British comedy troupe. So if you laugh and have a little fun while you're doing it right. So I think most people could guess that very accurately that the topic we're searching for is Obama. What is less clear is what the other arguments mean. Python, you don't have to use keyword arguments most of the time, but you should. And you put them in anywhere where somebody might misread this. So this code becomes profoundly better if I say the number of tweets is 20, the number of retweets is false, or that I don't want retweets, I want original tweets. In Unicode, I would like to allow that so I could find out what they're saying about Obama in other languages. Is this code profoundly better? That one of the simplest things you can do to improve the quality of your code is to use keyword arguments anywhere the names aren't simple. Remember, the code was PEP 8 compliant before, but it's better now. Good function names matter. All right, here's some fairly straightforward PEP 8 compliant code. We've got a simple tuple. You guys know about tuples? Immutable or immutable? Immutable. What's the length of this tuple? 3. How do I extract the 170? P square bracket 0. How do I get the 0.1? Can I unpack a tuple? So you guys all understand tuples. Okay, so you understand this. And this P square bracket 1 is going to look up which number? 0.1. Is 0.1 bigger or smaller than 0.5? Smaller. So is it going to say, phew, that's bright? Okay. How about this one? Will this if clause trigger printing, wow, that is light? So 100% of you in here understand this code. Every single person accurately predicted what it's going to do, and it's PEP 8 compliant. It also sucks, because you guys can't answer a fairly important question. Well, I actually think you can answer, but I could be wrong. In this audience, there might actually be a handful of people who know. Would you wear this tuple? There's somebody who might actually know. I know that some Pythonistas are photographers. That's exactly it. $5. Somebody figured it out. Isn't it great when you write code that's PEP 8 compliant and out of a room of 500 people, one person can figure it out? That's a goal to strive for. I know what you're thinking. I'm doing this live on stage for a reason. One of the reasons is I want you to have been very conscious of how long it took me to do it. Is that 10 to 15 seconds? Not done in the calm of the green room, but with lots of people watching over your shoulder, ready to make a cat call the moment you make a typo. Somebody say, or some Emacs weenie saying, well, you should have just used Control-Alt-QX exclamation point with your left pinky, and that would have done it. It takes so little time. It is so easy to do. If you don't do this, you're a fool. The code is profoundly better. The repper for this will say this is a color whose hue is 170 on the color wheel, 170 degrees, lightly saturated, highly luminous. It's a tinted color in photographer terms. The code is now profoundly better. This is one of the easiest ways to clean up your code. When you're done with this talk, first thing you should do, go eat. Second thing you should do, go back and look at your own code base and say, do I have a bunch of tuples floating around that aren't self-documenting? If so, fix it. It's only a couple lines of code. Make a named tuple. Named tuples are your friend. Who made named tuples? Oh, I did. Do you like them? Who in here doesn't like named tuples? One person. That's because you looked at the source code and you saw that I used a val, and it makes you mad, doesn't it? Even though I chose it for sound business reasons, like now everybody can understand the code, I never get a question on how named tuples work because they're self-documenting. It's also very easy to maintain, and you can print out the template so you don't have to use a val at all. And you can cut it out, go run it through PyPy, run it through Python, and get an optimized named tuple. It has a huge number of advantages. But a val makes you mad, doesn't it, sir? You know, Guido used a val when he made a time-it module. You should go let him have it during lunch. Yeah. You know, if that Raymond is using a val and Guido's using a val, that is 2 hints that you're doing it wrong. Okay. Fair enough. I hope you guys like a name tuple. And a val is one of those things you want to be cautious with because it's very easy to introduce security risk with it. On the other hand, if you are cautious with it, it can introduce great simplifications to your code. And so you shouldn't chop off your left arm, right arm, one of your legs, and your other leg while trying to prevent King Arthur from crossing. Don't throw away a val. It's one of your most powerful tools. Okay, get quotes. This is PEP 8 compliant code, and it uses a dictionary comprehension. What does it do? It gets a bunch of quotes. Sir?
Hi. Sorry.
Am I
As we're kind of running out of time and we've got to get to lunch, as you said, first thing we do is go and eat. Could we close this over and...
Yes.
Excellent.
And do I still have time for Q&A or no?
No.
Oh, okay.
Yeah.
He says, can you be brief? Yes. The thing that bugs me here is args. The args represent stock symbols. Why does it matter? In C, it doesn't matter what variable name you use there because the parameters aren't exposed to the user. But in this case, in Python, the parameter names are exposed to the user. Your parameter names are part of the API. They will see them, and that makes this more self-documenting. And then lastly, I have the looping over the interfaces. What's wrong with that code? The only thing that's wrong with it is it's fragile. And we can make it less fragile. There, I'm done.
All right, thanks very, very much. Thank you very much, Raymond. Clearly, there's a lot beyond PEP 8. And yeah, so as a note of logistics...
One more thing. Who learned something new? Okay.
Lunch is downstairs in the expo hall. That's room 210. And yeah, so go eat, and next session's in an hour.